Hello, everyone. My name is Jacob Alagasao, and today our group is going to report about the Chapter 2, Designing the Highway. And this report is presented by our group, Blacklist, and the members are Jacob Alagasao, Louis John Equipado, Baldwin Kifo Serafin, Carlito Mahina Jr., and John Gabriel Gilon. Consistency. Consistency is the most important single rule in the highway design. That is, by making every element of the roadway conforms to the expectation of every driver. Among the promising approaches to improve highway safety performance is the concept of highway design consistency. Drivers expect the highway agency to provide them with clear information and guidance through a variety of road signs and avoiding abrupt changes in the traffic as well as the road standards. If these guides and directions could be planned properly to convey one single message at a time, and if these directions could be followed smoothly and easily without undue haste or changes in speed, then the road facilities are considered satisfactory, meaning if we're able to follow directions smoothly, then there will be no problems. Experienced highway engineers recommend that highway signs and directions should be integrated as early as preliminary layout studies. Now, AASHTO is the American Association of State Highway and Transportation Officials. In 1914, the American Association of the State Highway Officials, or AASHTO, as was established as an association of state, territorial, and district of Columbia Highway Department and the Federal Highway Administration. The name was expanded in 1973 when the Department of Transportation was integrated into the association, renaming AASHTO to AASHTO, giving the officials of this agency the power to govern its operation. Engineering activities were implemented by standing committees with the task of preparing specifications, manual, and standards representing the current highway engineering practice. AASHTO publications include transportation materials, specifications and test, specifications of highway bridges, geometric design standards, and numerous policy statements and guides. AASHTO publications are authoritative, meaning it is reliable as the information are accurate or true. References are made in these books and periodic manuals. The association also publishes the AASHTO quarterly reports on current highway and transportation subject, including trends in forecasts and legislations. Roads and highway. Roads and highway is defined as strips of land that had been cleared and further improved for the movement of the people and goods. Road has a somewhat broader application in usage while generally used to describe public thoroughfare. A road is a wide way leading from one place to another, especially if the specially prepared surface which vehicles can use, and it can also refer to railways. Highway. The term was first used in England to describe a public road built by digging ditches on both sides and heaping up the earth in the middle, creating a way higher than the adjacent land. Basically, it's a major road, usually in rural areas or big roads. Highway now connotes a higher state of development than road, but the words are almost interchangeable. Expressway is a divided arterial highway for through traffic and with full and partial control of access and generally provided with grade separation at major intersection. It is a wide road for fast-moving traffic. Freeway is an expressway with full control of access. Control of access is a condition where the rights of the owners or occupants of adjoining land or other person's access to light, air, or view in connection with the highway is fully or partially controlled by public authority. There are two types of control of access, the full and the partial control of access. Both of them has the authority to control access and are exercised to give preference to through traffic by providing access connection to selected public roads, but the difference between them is the crossing at grade or direct private driveway connection is not permitted, while in partial control of access, the crossing at grade and private driveway connection are allowed. Through street or through highway. Every highway or portion thereof on which the vehicular traffic is given preferential right of way and at the entrance to which vehicular traffic from intersecting highways is required by law to yield right of way to vehicles on such through highway in obedience to either stop or sign or yield signs erected thereon. It is a street where vehicles passing through have the right of way as opposed to vehicles from intersecting roads which are obligated to stop before entering. And ang may uban nakabutang na not through street which is gitawag na tong dead end and or one street na no cross streets. Parkway. Parkway is an arterial highway for non-commercial traffic with full or partial control of access, usually located within a park ribbon or parklight development. Arterial street is an arterial route that carries traffic to the nearest access point or through tap traffic. Arterials provide access to the adjacent property, but often with restrictions on entry and exit points. It is a wide road, usually divided with an area of grass and trees on both sides and in the middle. Highway and parkway might be sound the same sometimes, but the difference between a highway and a parkway is that highway mainly has two or more two lanes having no tolls through in it, and parkway on the other hand is a decorated road and has traffic signals too. There are basic considerations in planning arterial roadways. First is selection of the routes. Of course, it is important to know the best place to build arterial. Two is studies of the traffic volume, like learning about how much traffic it can divert from one place. Three is origin and destination, the location of the arterial roadway and how far it will go. Four is accident experience. Width should not be less than 15 meters, must carry at least one lane or traffic in each direction, should be at least 1 kilometer in length, should skirt neighborhood areas rather than penetrate them. On grade design system street, arterials are spaced at about 600 and 900 meters apart. And when accident hazard is not a factor, the minimum volume to justify arterial road is 300 vehicles per average hour during the day and 450 vehicles hourly during peak periods. Sometimes peak hour traffic volume on designated arterial road exceeds the capacity of two-way streets. Now, to increase the arterial capacity, the following solutions are enforced. During peak hours, parking is prohibited on one or both sides of streets. Parking is prohibited several meters away from each side of the road intersections or corners, and right turn is allowed on red signals anytime with care. Left turns are eliminated on congested intersections, and the direction of the traffic is reversed in the center lane to provide more lanes in the direction of heavier traffic flow. Collector Street. It is a street form, smaller mesh grid pattern where passengers are picked up from service streets and carried to the arterials. Large commercial enterprises or amusement facilities like drive-in theaters are mostly fronting arterial roads. More like sumpay ni siya sa arterial roadway, like a street padong sa arterial roads. So Local roads is defined as a street or road primarily for access for residents, business, or other adjoining properties. It is also defined as a road constructed and maintained by the local government. Refer to local roads or street na accepting traffic from collector streets and distribute the traffic through subdivisions, neighborhoods, and business areas to individual homes, apartments, business sites, and industrial sites. Highway capacity. Highway capacity is defined as the minimum number of vehicles that are reasonably expected to pass a given point over a given period of time, usually expressed as vehicles per hour. And under ideal conditions, one freeway lane can be accommodated about 2,000 passengers cars per hour, and a two-lane road can carry up to 1,000 passenger cars per hour in each direction. There's an obvious relationship between vehicle speed and highway capacity. As the volume of the traffic approaches capacity, the average speed is markedly reduced. Average annual daily traffic, or AADT. AADT or ADT refers to the traffic volume or flow on a highway as measured by the number of vehicles passing as partial station during a given interval of time. It is called average annual daily traffic if the period is less than 1 year. Volume may be stated on hourly observed traffic volume or estimated 30th hour volume commonly used for design purposes. Some highways agency use traffic volume for 5 minutes interval to distinguish short peak movements of vehicles. This is determined by counting the total numbers of vehicles to cross a point of both direction on a highway during a year and dividing this value by the number of days in that year. So example, okay, ADT is equals to total volume of vehicles traffic for 1 year. I-divide na to siya of 1 year, so 365 days. So design speed. There's no single set of geometric standards that will apply to all highways. For every highway segment, decisions regarding appropriate control for each of the many details or requirements must be addressed individually or separately. AASHTO define design speed as the speed determined for design and correlation of physical feature of a highway that influence vehicles operation. It is the maximum speed that can be maintained over a specific section of a highway when weather and traffic conditions are so favored the design feature of the highway governed. AASHTO recommended that the design speed be set to the greatest degree possible to satisfy the needs of nearly all drivers both today and throughout the road anticipated life. For economic reasons, the geometric feature of a certain road section are designed for speed from 30 to 50 kilometers per hour, and yet some motorists drive faster on a straight road alignment or less sharply curved sections. Under these situations, highway design adaptive control by reducing the super elevation combined with easement curves, delineators, stripping signs, and rumble strips to alert motorists and inform them that they are approaching sharp or blind curves. Selection of the proper road design speed is one of the most important decisions to make because it sets the limit to curvature, sight distance, and other geometric features. But because of the limited funds, there's a strong temptation to reduce this design speed. Such kind of decision is unwise because the alignment grade and sight distance after the roadway has been constructed and paved along the landscape and right-of-way become more difficult and expensive to adjust or to correct. The AASHTO practice is to classify first the highway as rural or urban, then as freeways, arterials, collectors, and local. Rural collectors and local facilities are classified as flat, rolling, or mountainous. Although the design speed percentage used is 80 km per hour, highway designers project the design speed up to 120 kilometers per hour to guarantee against the future obsolescence as well as the increased margin of operating safety. The high-speed road design must anticipate future generation of high-speed vehicles and advanced transportation systems that may operate on many of these road alignments. Although the design speed of more highways is governed by construction cost, the concept of the relatively high-speed design for freeways is regardless of cost. They are planned for a nationwide high-volume traffic and high-speed network. So in this table, you can see the freeway in urban and rural areas has a preferred design speed. Also in arterial, collectors, and local, they also have a designated speed in both urban and rural. So in table 2, it shows that the AASHTO minimum design speed of rural collectors and local roads based on current ADT. The cross-section of a typical highway has a latitude of variables to consider, such as the volume of traffic, character of the traffic, speed of the traffic, and characteristics of motor vehicles and the drivers. Highway designs usually adopted cross-section that is uniform in thickness from end to end of the improvement. This is acceptable on high-volume traffic road facilities. For a low-volume traffic facilities, modifications of the features like the soldiers' width in rough areas are usually employed to reduce costs. A cross-section design generally offers the expected level of service for safety and recent study. Highway design usually adopt a cross-section that is uniform in thickness from end to end of the improvement. This is acceptable on high-volume traffic road facilities, but for a low-volume traffic facilities, modifications of the features like shoulders width in rough areas are usually employed to reduce cost. A cross-section design generally offers the expected level of service for safety, and recent study shows that a 7.20 meters wide pavement has 18% less accidents compared with a pavement narrowed than 5.50 meter wide. A 720 meters wide pavement has 4% fewer accidents than the 6 meters wide roadway. And accident record shows no difference between the 6.60 meters and 7.20 meters wide pavement. For the 6 meters and 7.20 meters wide pavement with 2.70 to 3 meter wide shoulder, recorded accident decreased by 30% compared to a 0 to 0.60 meter wide shoulders and 20% compared with a 0.90 to 1.20 meters wide shoulder. It appears that the above difference in accident potentials may not justify higher standards, particularly when traffic volume is low. The driver's instinct when overtaking or allowing other cars to overtake or meeting oncoming vehicles is to look at the surface width of the highway and see the kind of surface where to position his car. Originally, the total surface width of the roadway was only 4.50 meters, but due to the increase of number of vehicles using the roadway, the width was adjusted to 4.80 to 5.40 meters. Lately, the width of the road was standardized to 3 meters for first-class paved one-lane highway, and now 3.60 meters wide surface was adopted standard for freeways and other major traffic roadways, although there are strong demands to increase it further from 3.60 to 4.20 meters. For two-lane rural highways, a 7.20-meter wide surface is required for safe clearance between commercial vehicles and is recommended for main highways. And for collector roadway, a 6-meter wide surface is acceptable only for low volume traffic, including few trucks are traveling thereon. And for local rural roadway, the minimum surface width is 4.80 meters for a 30 kilometers per hour design speed. And for urban roadway, the minimum design width is 3.60 meters, although 3 meters is allowed where space is limited. So this is the cross-section of a typical two-lane highways and a multi-lane highways and freeways, or as half section. So this is the divided highways where it is a less than 100 kilometers and a 2.50 stop lanes, or less than 60 kilometers, 2.50 stop lanes. And this is the undivided highways where speed is less than 100 kilometers per hour for 3.50 lanes and 250, and a 3.50 lanes and a 2-meter stop lanes. Road shoulder. Road shoulder or verge is defined as the portion of the roadway between the edge of a traffic lane and the edge of a ditch, gutter, curb, or a side slope. So this is muna siya ang shoulder road na to. Nani where side dra mo park ang mga truck na nga. So the importance of the road shoulder is road shoulder serves as a place for vehicles to stop when disabled or for some other purposes. Road shoulder considerably reduces road accidents. The road capacity is decreased and accident opportunities increase if a shoulder road na to is too narrow or omitted in design. Shoulder should be continuous along with the full length of the roadway. It also adds structural strength to the road pavement. Shoulder increases the horizontal side distance on curbs. It reduces accident potential when vehicles stop during emergencies. Most of the road shoulder in rural areas are unpaved or having a width of 60 to 120 centimeters wide, either earth-filled or gravel surface that during rainy days, the drivers are hesitant to occupy. A continuous narrow white line strip at the edge of the roadway that separates the shoulder serves as the guide to drivers during the bad weather and poor visibility conditions. The white strips tend the drivers to stay in the traffic lane and the vehicles seldom infringe on the shoulder. So the policies on geometric design recommended that outside shoulder should be paved for at least 3 or 3.60 meter wide if truck volume is more than 250 in the design hour. The recommended width of left or median shoulder is 1.20 to 2.40 meters with at least 1 meter paved. If there are 6 or more lanes, the median shoulder should be 3 meter wide or 3.60 meter if truck volume in the design hour is exceeding 250. For arterials with ADT less than 400, the usual shoulder width is fixed at 1.20 meters minimum, although 2.40 wide is much preferred. When the design hour volume ADT exceeds 400, the usual minimum shoulder width is 2.40 meters, although 3.60 meters is recommended. For urban arterial road, similar shoulder without curve is suggested unless for urban arterial road, similar shoulder without curve is suggested unless needed for proposed drainage. The width The median shoulder on 4 lanes divided arterials is fixed at 90 centimeters as minimum. For 6 or more lanes, 2.40 to 3 meters shoulder width is recommended. And for rural collector roadway, 60 meters wide graded shoulder is required for ADTs less than 400. And for ADTs over 2000, 2.40-meter wide shoulder is recommended. And as the tables show, this is the width of the roadway for undivided highways. So these are the design for a shoulder road, which is the street alignment, shoulder details with stop lane. And these are the design for street alignment, shoulder detail with stop lane, guardrail. Guardrail kay katuman ng kuan, a rail that prevents people from falling off or being hit, more like a coral. More siya coral sa kalsada. So this is the straight alignment shoulder detail with stop lane used as cycle path or footpath. So ang design ani kay wag na siya bike lane or dira pwede manlakaw. So diri kay no stop lane, no footpath or no guardrail shoulder. So sa figure, this figure should, so in this figure, the shoulder detail is footpath only. So the last is the alignment and curved shoulder details. Nay, duha ka buhok inside shoulder and outside shoulder. So outside shoulder can I pave and napoy stabilized. Next is this cross slope, which will be discussed by our next reporter.